Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next test question. We have to find this limit here, the limit as x approaches 3 of x squared minus x minus 6 all over the absolute value of x minus 3. So notice this absolute value. Usually when you see that, you know you're going to be dealing with a one-sided limit. I've went through a bunch of examples, different scenarios in the lecture videos, so make sure in addition to this you go through those as well, because there are different scenarios that can come up, and so you want to be comfortable with all of the possible ones. But dealing with this one here, what's the first thing we always check with a limit? Can we do a direct substitution? And notice that we can't, because if we sub in 3 in the denominator, that will be 0. It will also be 0 in the numerator. Actually, if you notice, the numerator factors, right, into x minus 3, x plus 2. So let's make that the first step right there, and then it's easy to see, right? It would be 0 here, it would be 0 here, so you'd have 0 over 0. It's in that indeterminate form, so we can't just do a direct substitution. So what I'm going to do first is let's actually take this absolute value of x minus 3 to the side. And if you remember, what does an absolute value do? Well, it takes any value that's already positive and keeps it like that, right? The absolute value of positive 5 is just going to be positive 5, right? So if the expression in the absolute value is going to be positive, we just keep it as it is. However, if it's going to be negative, we have to turn it into a positive, and the way we do that is by multiplying it by -1, right? So if we have like the absolute value of -5, that would equal positive 5. And if you think about it, what's going on in the background is we're taking that -5 within the absolute value, multiplying it by -1 to get this positive 5. So if we generalize it for this particular absolute value, so it's going to stay as x minus 3 when x minus 3 is positive, right? If it's positive, it's just going to stay how it is. However, if x minus 3, if that expression under the absolute value is going to be negative, we're going to multiply that entire expression by -1, right? I just put a negative in front, but it's like a -1 that's in front of the bracket, right? And multiplying that negative expression by -1 is going to turn it positive. And so if we simplify this a little bit more, we could say that, okay, this absolute value as a piecewise function is going to stay as x minus 3. And now here, let's isolate for the x. So when x is greater than 3. Right? If we bring the -3 over, then over here, I'm actually just going to keep it like this for now. So we're going to multiply that x minus 3 expression by -1 if x is less than 3. Right? And then you could test it out. So if I plug in like an x value greater than 3, let's say 6. 6 minus 3 is positive 3. Right? And so it's just going to stay as it is. However, if x is less than 3, let's plug in like 1. 1 minus 3 is -2. And so we would have to multiply that -2 by a -1 to make it positive 2. All right, so that's what's going on there. And so now that we have an expression for this absolute value of x minus 3, we split it up into a piecewise function. Let's apply that to this entire function that we're finding the limit of, right? So we could say that x minus 3, let's take it to the side, x minus 3, x plus 2, over the absolute value of x minus 3, well, we could apply these pieces to this denominator, to that absolute value of x minus 3, and keep the numerator the same. So we could say that basically, if x is going to be greater than 3, then we're going to have x minus 3, x plus 2, right? The numerator stays the same, all over, let's maybe color coordinate this, all over x minus 3, right? That absolute value of x minus 3 is going to stay as x minus 3 when x is greater than 3 from here. Okay, but if x is less than 3, then over here for this entire function, the numerator stays the same. But what happens to the denominator? Well, the denominator is going to change to negative bracket x minus 3, like that. Right? And so notice that this is going to simplify here because the x minus 3's here cancel out and the x minus 3's here cancel out. And so what we're going to end up having is basically we're going to have x plus 2 when x is greater than 3, and we're going to have, there's a negative here, right? So we could put in front of that x plus 2 bracket when x is less than 3, like that. And then simplifying this, let's actually just distribute that negative inside the bracket. So this is when x is greater than 3, and this is going to be negative x minus 2 when x is less than 3, like that. Right? So this function here, the function we're taking the limit of, it simplifies into this piecewise function. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Right here, right? For x values greater than 3, it's going to, the y values are going to be defined by x plus 2. And when x is less than 3, the y values are going to be defined by negative x minus 2. And notice that at an x value of 3, this function is undefined, right? And so there is no definition for an x value of 3. It's only when it's greater than 3, and then when it is less than 3. Well, now because we are dealing with two different functions, right, to the right of that x value of 3 that we're trying to find the limit at, and to the left of it, we have to look at the one-sided limits. We have to approach this function from the right and from the left and see what happens. And if they approach the same value, the limit exists. If not, the limit is not going to exist. And so what I think is the best thing to do is to take this piecewise function and graph it. Now, to graph it, if you remember graphing piecewise functions, let's make a table of values for each of these pieces separately. So let's start if x is going to be less than 3, right, then the y values are defined by negative x minus 2. And so let's start at 3, even though it's not defined at 3. Remember when we graph piecewise functions, you always want to take it to the limit, and that's just going to be a hole, but you want to see where it's going to end, right? So plugging in a 3 here, we would end up with negative 5, and then all the x values less than 3, so let's do like 2, 1, and 0, right? You don't need, actually all you need is this. I'll mention that after, but I'm kind of taking the longer way so you can see visually what's happening. But making a graph is actually not fully necessary to do, but I do want to make one so you fully see also visually what's happening, right? So that table of values is for this piece, so let's color coordinate these. And then let's make a table of values for this piece right here, right? So x and then y equals x plus 2. So this is going to be all the x values greater than 3. So we still start at 3, 4, 5, 6. This is going to be what? Positive 5, 6, 7, 8, right? Just a simple line. And again, you could just tell we're going to be approaching negative 5 from the left side and then positive 5 from the right side, right, as we approach the that x value of 3 from both sides. So notice that these two values are different, and so the overall limit we know is not going to exist. But again, just want to do a quick visual and show you how this is looking. So basically, this graph is just going to be a quick rough graph. So basically at 3 and negative 5, that would be like a hole there, right? And it's basically a line, if you were to graph this, that looks like this, right? This part. And then this part here, it's, okay, we have an x value 3. It's going to be at positive 5. Right, and that's going to be a line with a positive slope, so it's going to look something like that. And now that we have this graph for this function, we can tell that the limit from both sides, it's approaching different values. Again, we didn't have to make the graph. We could just plug in 3 into those 2 pieces in the piecewise function and see it's approaching different values. But visually, this is how it is looking. And so if you want to like fully properly state that this limit does not exist, you would say, well, the limit as x approaches 3 from the negative side of this function, x minus 3x plus 2, over the absolute value of x minus 3, that limit, we're approaching this y value of negative 5, right? As we approach 3 from the negative side, we're approaching this y value of negative 5, and then the limit as x approaches 3 from the positive side or from the right side, right, we're approaching that y value of 5, right? So let's draw out this, or write out this limit fully, make it proper. So we would say that's equal to positive 5. And so because the one-sided limits from each side are approaching different y values, right, from each side of 3, approaching it from the left side, approaching it from the right side, we know that this overall limit does not exist. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.